Hello students, I welcome you all to my channel Engineers Academy. Do hit the subscribe button if you haven't done it yet. And now we are going to solve this problem which says that determine the magnitudes of couple moment M1, M2 and M3 so that the resultant couple moment is 0. So the resultant of these M1, M2, M3 and let's say this is M4 is equal to 0 on this assembly. So we have to find the magnitudes of M1, M2 and M3. So before going to find the summation, we have to find the Cartesian vector representation. We have to represent this M1, M2 and M3 and this M4 as a Cartesian vectors. So we can write that M1 Cartesian vector, this will be equal to, since the magnitude is not known but this is acting in the direction of positive y, so we will write that its I component is 0, its j component is plus M1 j plus 0k, since it is only acting along the y-axis, so its I and k component must be equals to 0. Similarly, M2 is acting parallel to the x-axis, but it is acting in the negative x, so its j and k components are 0. We will write M2 vector, and M2 vector is 0i minus M2j, since it is acting in we will have minus M2i plus 0j plus 0k. Similarly, we have to find the Cartesian vector representation of M3. It is actually from this particular point to this particular point. So let's name these 2 points. Let's say this point is A, this is B. So this is point A and this point is B. So we have to write M3 Cartesian vector. This will be equal to M3 times the unit vector, or we can say that the dot product of the unit vector from A to B. This is M3 magnitude. So M3 magnitude times the unit vector from A to B, and this is equal to M3. And the unit vector is the position vector from A to B divided by the magnitude of that position vector. So M3 Cartesian vector, this is equal to M3 magnitude. And we have to find the position vector from A to B. So from A, we need to travel 2 feet in the positive x. So plus 2i. Then from here, we need to travel 2 feet in the negative y. So I will write minus 2j. And then from here, we need to travel 1 feet in the positive k. So plus 1k. And then we have to find the magnitude of this position vector from A to B. So this is 2 square plus 2 square plus 1 square. And this will be equal to 3. So the magnitude of the position vector from A to B is 3. So this is, we need to divide each component by this resultant, and then by this magnitude, and then we have to multiply it with M3. So this will be, we can write that M3 is 2 divided by 3 M3i minus 2 divided by 3 M3j and plus 1 divided by 3 M3k. So this is the Cartesian vector representation of M3. So let me write that M3 here. This is M3. This is plus 2 divided by 3 M3i minus 2 divided by 3 M3j plus 1 divided by 3 M3k. Similarly, this one is M4, let's say. So then we have to represent this M4 as a Cartesian vector. So M4. So this M4 will have one component like this and one component like this. This particular component is in the XY plane, and this component is in the negative Z. So this component is from this triangle which is standing on the XY plane. We can say that this is the Z component of this M4, and this is acting in the negative Z direction, and this will be 150 sine of 45. So 150 sine of 45 is 106.06. So this is in the negative k. So we will write that minus 106.06 k. Similarly, we will have one component in the XY plane. This component will be 150 cos of 45. So 150 150 cos of 45, and similarly we can resolve this into x and y component. We will have these two components, so we will have one component like this and we will have one component like this. So this one will be the cos component of this component, so this component will be, this will be 150 cos of 45 and this component will be, this component will be 150 cos of 45 sine of 45. So now this component is in the positive x, and 150 cos of 45 sine of 45 is 75. So this is 75 in the positive x, so you'll write plus 75i, and this is in the negative y, that is in the negative j, and 150 cos of 45 into cos of 45 will also give us 75. So this is minus 75j. So this is the Cartesian vector representation of that M4. And when we add up all of these components, the resultant couple, we can say that the resultant couple is 0i plus 0j plus 0k. Since we are given that determine the magnitude of the couple moments M1, M2 and M3, so that the resultant couple moment is 0. So the resultant is 0. So this means that the sum of the I component is equal to 0, the sum of the j components is equal to 0, and the sum of the k component is equal to 0. So now if we add up the I components, the summation of I components, so that will be 0 minus M2 plus 2 divided by 3 M3 plus 75, and that will be equal to 0. So this is 0 minus M2 plus 2 divided by 3 M3 plus 75 equals to 0. So now this is equation 1. So this is minus M2 plus 2 divided by 3 M3 plus 75. This is our equation 1. Similarly, if we add up all the j components, so that will be plus M1 minus 2 divided by 3 M3 minus 75, and that is equal to 0. So now if we add up, let's say this is equation 2. So now if we add up both of these equations, right? If we add up both of these equations, so this is plus 75, this is minus 75. This will cancel out. This is plus 2 divided by 3 and this is minus 2 divided. This will cancel out. So we will have minus M2 plus M1. This is equal to 0. And from this we can say that M1 is equal to M2. So M1 and M2 magnitude are equal. Similarly, if we add up the summation of moment about the k components, if we add up all the k components, so that will be 0 plus 1 divided by 3 M3. I will write plus 1 divided by 3 M3 minus 106.06. This is equal to 0, and from this we can say that 1 divided by 3 M3 is equal to 106.06, and from this we can say that M3 is 3 times 106.06. So 3 multiplied by 106.06, this gives me M3 equals to 318.18 pound feet. This is M3 magnitude, in order to have that resultant equals to 0. And now we know that M1 is equal to M2, and we know M3 magnitude. We can substitute all these in this, either equation 1 or in equation 2. So let's say if we put in equation 1, so in equation 1 we have minus M2 plus 2 divided by 3 M3. M3 is known, which is 318.18, and plus 75. This is equal to 0. So now from this we can say that minus M2 is equal to minus 2 divided by 3 into 318.18 minus 75. So this is minus 2 divided by 3 into 318.18 minus 75. This is minus M2 equals to minus 0.12. Dividing both sides of equation by minus 1, we will get M2 equals to 287.12 pound feet. And since we have determined that m1 is equal to m2, so we can say that m1 is equal to m2 is equal to 287.12 pound-feet, and m3 is 318.18 pound-feet, in order to have the resultant couple moment equals to 0. So this is the solution of this particular problem. I hope it will help you in your learning. Do subscribe Engineers Academy for the solution of such more problems from Hibbeler Statics.